Hello students, we are studying CBSE 10th standard and we are studying lesson number first, and name of the lesson is there chemical reactions and equations. So in this lesson, in this topic, before this we have studied what I mean by chemical reaction. After that we have studied about definition of chemical reaction, as well as after that we have studied how to write the chemical reaction, how to make chemical reaction more informative. Now after this, some sign convention also we have studied. After this we are going to study about chemical equation, and in that chemical equation whether that chemical equation is balanced or unbalanced. We have to study whether that chemical equation is balanced or unbalanced. So we'll write that point, which point we are going to study. So balanced and unbalanced, balanced and unbalanced chemical equation, balanced and unbalanced chemical equation. So in 9th standard we have studied Dalton's theory of atomic model, and according to Dalton's theory of atomic model, we have studied in case of the Dalton what he given about some assumptions, conclusions given by the Dalton. These are: atom can neither be created nor destroyed. So you cannot create atom, you cannot destroy atom. Another one more thing we have studied, and that one is the Anthony Lavoisier's law of conservation of mass. In 9th standard we have studied law of conservation of mass. So what is law of conservation of mass, and who given this law of conservation of mass? That one we'll see. So law of conservation of mass was given by Anthony Lavoisier. Name of the scientist is there, Anthony Lavoisier. So this Anthony Lavoisier, he given law of conservation of mass, and according to his law, what he told: mass cannot be created, mass cannot be destroyed. Mass cannot be created, mass cannot be destroyed. That means mass of the reactant before chemical reaction is equal to mass of the product after chemical reaction. So according to law of conservation of mass is there. What is the law? I will write that law. The mass of or total mass of, also you can say the total mass of reactants before chemical reaction, total mass of the reactants before chemical reaction is equal to total mass of products, after chemical reaction, So simply this law is there. What this law tells: so mass of the reactant is equal to mass of the product. Mass of the reactant is equal to mass of the products. That means we can write mass of the reactant before chemical reaction is equal to mass of the product after chemical reaction. That means you can say mass cannot be created, mass cannot be destroyed. So according to this, whatever chemical reaction, chemical change we are writing, so whatever chemical equation we are writing by using symbols and chemical formulae, so according to this law of conservation of mass, so mass of the reactant should be equal to mass of the product, and if it is equal, then you can say it is chemical equation, or that chemical equation is balanced. So after this, next part we have to study what do you mean by balanced chemical equation and what do you mean by unbalanced chemical equation. So first of all, we'll see balanced chemical equation. or first we'll take unbalanced and then we'll take balanced chemical equation. So unbalanced chemical equation. Unbalanced chemical equation. So you can write, you can tell definition. So total, or you can say in a chemical reaction, if number of atoms present in the reactant side is not equal to number of atoms present into the product side, then that chemical reaction is not balanced. What I am saying, if number of atoms of each element present in the reactants is not equal to number of atoms of same elements in the product side, then such chemical equation is called unbalanced chemical equation. It is called as an unbalanced chemical equation. So what I am saying, that one try to understand, if number of atoms of each element present in the reactant is not equal to number of atoms of the same elements present in the product side, then such chemical equation is called as an unbalanced chemical equation. And again one more thing is there, such equation, or you can say unbalanced chemical equation is also called as skeletal equation. So you have to underline to the skeletal equation. If that chemical equation is not balanced, then you are saying it is unbalanced chemical equation, or you can say skeletal equation. So example I will tell. Suppose you will take a simple example, magnesium reacts with oxygen and it gives magnesium oxide. It is giving magnesium oxide, MgO. So here magnesium is there one, in the reactant side magnesium is there one, in the product side also magnesium is there one. Here oxygen in the reactant side is there 2, but in the reactant side it is 2, but in the product side it is 1 only. So here of magnesium 1, oxygen 2, oxygen 1. So chemical equation is not balanced. So number of atoms of each element in the reactant side is not equal to number of atoms of same elements into the product side, then you can say this chemical equation is not balanced. And that chemical equation is called as a skeletal equation. So after this, next point we have to study, and that point is there. So one more thing is there. If chemical equation is not balanced, but what Anthony Lavoisier's law is telling, or law of conservation of mass is telling, that law of conservation of mass is saying number of atoms or mass of the reactant is equal to mass of the product. But here, if our number of atoms will not be same, then mass will not be same. So you have to balance that chemical equation, and that how to balance that chemical equation we are going to study in the next part. after next one point we are going to study how to balance the chemical equation. So next point I am going to take, and that one is the balanced chemical equation. Next point I am taking, and that point is the balanced chemical equation. So balanced chemical equation. So definition is also there. I will tell first definition and then I will write on the board. So if number of atoms of each element present in the reactant side is equal to number of atoms of same elements into the product side, then you can say that chemical equation is balanced. Or simple way is there, number of atoms present in the reactant side is equal to number of atoms present into the product side, then you can say this chemical equation is balanced. So definition will write, if number of atoms of each element elements present in the reactant side is equal to number of atoms of same elements in the number of atoms of same elements in the product side, then such chemical equation is called balanced chemical equation. So this is definition for the balanced chemical equation. If number of atoms of each element present in the reactant side or reactant is equal to number of atoms of same elements present in the product side, then such chemical equation is called as a balanced chemical equation, and it is as per the law of conservation of mass. So one example we'll take, and that example is there in activity we have studied that example. If you take zinc granule and in that you will add sulfuric acid, then it is producing zinc sulfate plus hydrogen gas. That example I am going to take. So example is there, Zn plus H2SO4, and it gives ZnSO4 plus H2 gas. Zn plus H2SO4, zinc, you can write here zinc plus sulfuric acid, and it is giving zinc sulfate and hydrogen gas. So here if you will count number of atoms of each element, here zinc is there 1, hydrogen 2 is there, then sulfur, yes, 1 is there, yes is also 1 here, then oxygen 4 is there, 4 is there. So what you can say, number of atoms of each element in the reactant side is equal to number of atoms of same element into the product side. Then this chemical equation is called as a balanced chemical equation. So this is balanced chemical equation. So after this, and if chemical equation is not balanced, we have to balance that chemical equation, because as per the law of conservation of mass of the reactant should be equal to mass of the products. So this one is their balanced chemical equation. Previously we have studied unbalanced chemical equation. Now we are going to take some examples, and with the help of that example you will understand how to balance the chemical equation. So steps to balance the chemical equation. So that one we will study. Next point is there, balancing chemical equation. Next point is there to balance chemical equation. Balancing chemical equation. So in that balancing chemical equation, it is a, you can say, trial and error method is there. You have to try again and again, then you will go to the final conclusion. Trial and error method is there. So next point is there balancing a chemical equation. Chemical equation. How to balance the chemical equation? This point we have to study. So one example will take, whether that example is balanced or unbalanced we'll check, and then accordingly we'll study or we'll go stepwise how to balance that particular chemical reaction. So I will make some parts of that particular board because it is a long process. We'll understand how to balance that chemical equation. An example will take. One of the example is there. Example. So Fe plus H2O. So Fe is there. Iron plus H2O. Water vapor is there. Gaseous state is there, and it is giving, or it will form. So it will form Fe3O4. It will give Fe3O4, and plus hydrogen gas will be given out. Plus H2 gas will be given out. So I will write clearly here. Fe3O4 is there. Fe3O4. So here iron is there. Here water is there. Water vapor is there. Here you can say ferric oxide is there. FeRric oxide is there, and hydrogen gas is there. So if you count number of atoms of each element, then it is not equal to. So Fe in the reactant side, to the left of the arrow we are writing reactant, to the right of the arrow we are writing products. So Fe in the reactant side 1 is there, in the product side 3 is there. So the number is not balanced. Here hydrogen 2 is there, here hydrogen 2 is there, hydrogen's balanced, but oxygen here 1 is there, and here oxygen 4 is there. So oxygen atom is also not balanced to both sides. So there are some steps to balance the chemical equation. There are some steps to balance the chemical equation. We will take under that heading steps to balance chemical equation. Steps to balance the chemical equation. And the first step is there. You have to write given chemical equation as it is. Step number first you can take. Step 1. What is step? To write given chemical equation. Given chemical equation as it is. As it is. Alright. So given chemical equation we will write as it is. So Fe plus H2O, it gives Fe3O4 is there, plus hydrogen gas is given out. So here, as per the state board, the SSC board, Maharashtra state board, in that and in case of the CBSE, same method is there, little bit change given, and I will see first thing, step number second is there. In that step number second, we have to do boxes to the reactant as well as products. So making boxes to reactants and products. So chemical reaction as it is, we'll write Fe plus H2O, it gives Fe3O4 plus H2 gas. So here we are doing boxes here. We are doing here boxes. So Next thing is there, you have to examine, you have to check whether chemical equation is balanced or not. If already it is balanced, then no need to balance it. So third step, step number 3, examining whether equation is balanced or not. So how will you examine? So you will take that chemical equation as it is again, Fe plus H2O, it gives Fe3O4 plus H2 gas, and here you will make columns, and in that columns you will make table, and in the first column you have to write elements. Second column is there number of atoms in LHS or 2 LHS, and here number of atoms to RHS. So how many elements are there? So first element we will write Fe here. In the reactant side, that means in the LHS, how many Fe are there? Fe is there 1. In the product side, Fe how many are there? Fe 3 are there. After that, second element is there. Hydrogen will take H. Symbol for hydrogen is the H. To reactant side, how many are there? 2 are there. To product side, how many are there? 2 are there. After that, we will take oxygen. So in the reactant side, how many oxygen are there? Oxygen is there 1. In the product side, oxygen is there 4. Product side, oxygen is there 4. So here Fe1 is there, here 3 is there. Hydrogen 2 is there also 2. And here oxygen 1 is there, oxygen 4 is there. So number of atoms of each element in the reactant side is not equal to number of atoms of same element into the product side, and that's why we have to balance this chemical equation. So step number 4 will take. So you have to select, while balancing the chemical equation, you have to select that particular atom which will be convenient to balance. You have to select that particular atom which is convenient, easy to balance. Convenient means easy to balance, and while balancing that chemical equation, you have to consider that atom which should be or which should have, or that particular chemical substance, okay, and which is having maximum number of atoms. So here we will consider first oxygen. So to balance oxygen atoms, multiply. You have to multiply here. If you will multiply here by 4, then it will get balanced. So multiply oxygen of LHS by 4. You have to multiply oxygen of LHS by 4. You will multiply here. So you have to write change chemical equation. So Fe plus box is there. So you will write here 4 into bracket H2O. It gives Fe3O4 is there. Box you will write there, plus here hydrogen are there 2. Now again you will go. Again next thing is there. Again you have to examine. And if you will check here, Fe1 is there, Fe3 is there. Hydrogen 4 multiplied by 2. 4 2s are 8 is there, and here 2 is there. So here this chemical reaction is also not balanced. So you have to take one more step to balance that chemical equation. And how will you balance? Now step number 4. Each time you have to examine whether it is balanced or not. So step number 5 is there. To balance hydrogen to balance, or you will write hydrogen to balance hydrogen multiply hydrogen H of RHS, hydrogen of RHS by 4. It will multiply by 4. Then what will happen? Chemical equation will become Fe as it is plus H2O as it is. Box will do here, box also here, and here we are writing 4H2O. Then it gives Fe3O4. Again box you have to do plus 4H2. Okay. So hydrogen atom will get balanced. Now hydrogen here 4 2s are 8, 4 2s are 8. Hydrogen is also balanced. Now after that, next thing is there. Step number 6 will take. Step number 6. Now while balancing, now who remain? Iron remain. Here Fe1 is there, Fe3 is there. So next step will be there our to balance the, what you can say, Fe atom. Fe is not balanced. So to balance iron, multiply Fe of LHS by 3. If you multiply by 3, then it will become, the number will get balanced. So you will write here Fe plus H2O. Here you will multiply first time by 4, and here you will multiply by 3. Again here to right side Fe3O4 will be there, box. Then after that 4H2 will be there. Again here box is there. So now at last we'll examine whether chemical equation is balanced or not. Step number 7 will be there. Examine whether equation is balanced or not. Balanced or not. So again you will make column. Same will be there. Here element will be there. Then number of atoms, LHS will be there. Number of atoms to RHS will be there. And I will take here. So here Fe in this equation, Fe3 is there. RHS 3 are there. Then after that oxygen will take. Oxygen 4O. 4. O4 is there. 4. After that hydrogen 4 2s are 8. 8 is there. And right side 4 2s are 8. So here if you will see this table, in this you will observe Fe to LHS 3, RHS 3. Oxygen to LHS 4 to the RHS 4. And hydrogen to the LHS 8, RHS also 8. So this chemical equation, this one is balanced chemical equation. And step number last is there. Step number 8 will be there. 8. Write balanced chemical equation. Balanced chemical equation. So we'll write that balanced chemical equation. Fe 3Fe plus 4H2O. It gives Fe3O4 plus 4H2 gas. So like this way we have to do the boxes, and this is balanced chemical equation. Balanced chemical equation. And at last we have studied, you have to mention their states of all the reactants and products. So here Fe is there in the solid state, H2O is there in the gaseous vapor state is there, Fe3O4 is there in the form of solid, and H2 gas, it is in the gaseous state. So these are the steps to balance the chemical equation. and this method is called as a trial and error method. Which method is there? Trial and error method is there. So in this video we have studied balanced chemical equation, unbalanced chemical equation. Unbalanced chemical equation is also called as a skeletal equation, and as per the law of conservation of mass, we have to balance that chemical equation to make number of atoms to the reactant side is equal to number of atoms to the product side. So I hope you understood this one. You have to subscribe this channel, and you have to share this channel with your friends, and you have to make notes by looking this video, and you have to send to me. Okay.